10.4 is ellipses. An ellipse isn't just an oval. I know you think of it that way, but it's actually more specific than that. Before we describe what an ellipse really is, let's discuss what it has. They all have a center, which in this case is at the point 0, 0, but they're not always at 0, 0. From the center to the vertex, that's the farthest point. The farthest point has a distance of a units. The closest point we call the covertex. Those 2 points have a distance of b units. So every ellipse has 2 vertices, 2 covertices, and also 2 foci, a focus here and a focus here. 2 focus make foci. The foci have distances of c units. So there's an a distance, the long one, a b distance, the short one, and the c distance is somewhere between 0 and a. We can talk about ellipses like we did parabolas. Here's a point, here's an ellipse, and here's a parabola, a point D on the ellipse. Now the ellipse has 2 foci, a focus here at B and a focus here at C. If I measure the distance from D to B, right now it's almost 5 centimeters. And if I measure from D to C, right now it's 2.7. You'll see as D moves in this direction, the length of CD will increase, but the length of dB will decrease. You can watch that over here. You can see one gets bigger, one gets smaller. One shrinks, one increases, one shrinks, one increases. And pretty soon, they switch. Now dB is going to increase and dC is going to decrease. But the point is the 2 of these lengths added up will always sum to the same distance. As D moves, that sum, 7.76, always stays the same. And I can make the ellipse more and more circular or make it more and more elongated depending on how I stretch these foci, and you'll see it really stretch it quickly. In fact, if you break it all the way through, you get a new shape entirely. But if the 2 foci are on top of each other, you get a circle, and the closer they are, the more circular the ellipse, and the farther apart they are, the more extreme the ellipse. An ellipse follows this formula. A squared plus b, you have x squared. This formula here with x squared over a squared, or you can have y squared over a squared. The 2 important things to remember. The ellipse formulas use what I call the evil Pythagorean theorem, where it's a squared minus b squared instead of a squared plus b squared. And with ellipses, the a value is always the biggest one. So here, if the bigger number is underneath x, it stretches things left to right. This is a horizontal graph. In fact, I'm going to pull this down here. If the a value is underneath the y, if the bigger number is underneath the y, it stretches things vertically up and down. These points didn't move with that, but I don't really care. None of these graphs right now have had their center moved. If the center gets moved, you have this h and this k. So h and k moves your center to be at hk instead of 0, 0, and then you graph. So we'll do a few examples of how to work these out. I have the equation x minus 2 squared over 4 plus y plus 1 squared over 49 that I'm going to graph. Well, I identify a, b, c, h, and k. I'll start with h is 2 and k is negative 1, which gives me a center of 0.2, negative 1. Then I have an a value of 7 and a b value of 2. You'll notice that this is my a value because it's the bigger number. The bigger number is always your a value, the smaller number is always your b value. To find c, I would have to use evil Pythag. So I know that c squared is really 49 minus 4, so c squared is 45. So c is whatever the square root of 45 is. It would be a little bit under 7. Square root of 45 is 6.7. There's my C to go along with my A and my B. I don't actually need C for graphing, but C helps me find the foci, so I'll use it there. My A value of 7 means from the center, I'm going to go up 7 units and go down 7 units. 1, 2, 3, 4, 5, 6, 7. Because this came underneath the Y variable, well, Y is the up and down variable, so A tells me how far up and down to go. Likewise, my b value in this case, not in every case, but here, this tells me how far left and right to go. From the center, I'll go left 2 and right 2. Then I try my darndest to draw a good ellipse. If I had a piece of paper, I'd be kind of spinning the paper a little bit as I go. But that's the best ellipse I can draw in this case. Now the foci are at 6.7, so from the center I'll go up 6.7, and that puts me pretty much here, and down 6.7, pretty much there. And those are my foci. Look at this full screen so you can kind of see things a little bit better. It's enormous. But there's how I drew that ellipse as best I can. A and B and C always just stand for distances. Give me that. Here's another problem. I need to put this in its elliptical form. So I'm going to complete the square. I'm going to get the x's together. 4x squared plus 16x plus y squared minus 2y. And I subtract this 1 from both sides, so I get this. Now on the left side, with the x's, I have to factor out a 4. Don't divide by 4. If you divide everything by 4, you'll get a bunch of fractions. Fraction here, fraction here, fraction here. We don't want fractions, so don't do that. So factor out the 4. Now I complete the square. Over here, my b value is 4. So b over 2 is 2. And b over 2 squared is 4 again. So I'm going to add a 4 here. You've seen me add 4 and subtract 4 in parabola problems. But here, instead of adding and subtracting 4, I think it's easier to add a 4 here. To add a 4 here, but recognize that was really 16. So add the same thing over here. Add 4 times 4 on that side. When you add a 4 in that parentheses, it's being multiplied by whatever this number in front was. Here, my b value is 1, so I'll add a 1 here, and add a 1 here. This now gives me, as I complete the square, 4 times x plus 2 squared plus y minus 1 squared equals 16. Now to have an ellipse, I need it to be equal to 1. So I'll divide everything by this coefficient here, or that number 16. When I do that, I'm just going to reduce. So 4 over 16 here, 4 over 16 just becomes 1 over 4. So it's x plus 2 squared over 4 plus y minus 1 squared over 16 equals 1. Now I can graph this. I have an A, B, and H, and a K. My center is going to be at the point -2, 1. And so what I do is I just take that center and put it in the middle of my grid. And then I build everything around that. So I put an x-axis here, and a y-axis here. There's the point -2, 1. That's the center of my graph, of my ellipse. Now I measure out some distances. This thing is going to move up and down 4. Up and down 4, and left and right 2. My a value is 2, and my b, oh, this doesn't matter, just a and b. Square root of 16 is 4, square root of 4 is 2. So I go left and right 2, up and down 4, and I've got my ellipse. This one also had a vertical orientation like the last one did. If I wanted to find my foci, I would find the c value, so that'd be a squared minus b squared is c squared. This is the only time where it matters that a has to be bigger than b, because that means you get a positive number as you solve. It's root 12, we're going to say it's 3.5. I don't really know what it is, so we'll just call it 3.5-ish. Right around there, those are my foci. This point right here would be a vertex, this would be a vertex, this would be a co-vertex, this would be a co-vertex. Finally, if we're given an ellipse with a center at 0, 2, I'm going to mark that. Here's my center, 0, 2. A focus at 6, 2, and a vertex at 8. Write the equation of the ellipse and graph it. Well, because these things are symmetric, I can also go, the distance from here to here is 6. So I'll go 6 in the other direction also. I'll go 6 here, 1, 2, 3, 4, 5, 6. There's another focus. There's another vertex. Well, now I know that my C value is 6 and my A value is 8. Knowing that, I can find the B value using evil Pythag. A squared minus B squared equals C squared. So 64 minus B squared equals 36. So negative B squared equals negative 28. So B squared equals 28. So B equals whatever the square root of 28 is. 5.3. Check my math real quick to make sure that's all okay. I think I'm all right. So from my C value, my center, I can go up 1, 2, 3, 4, 5.3, and down 1, 2, 3, 4, 5.3. At this point, I've got the best chance at an ellipse I'm going to get. This one has a horizontal orientation, all the other ones had a vertical orientation. Not a great ellipse. What's sad is I can actually check how bad my ellipse is. I can go like this and see, oh man, it was supposed to look that pretty bad, but we're going to live with it. Now, I'm going to write the equation. Ask me to write the equation. It doesn't really matter which comes first, x or y. I always do the x's first. So this is going to be the point x minus 0 squared, which is really just x squared. So it's going to be x squared over my a squared value is 64, plus my y got moved, so it's y minus 2 squared over my b value here is 5.3 squared, which b squared is 28. So we know it's equal to 1. There's the equation, there's the ellipse. To recap, ellipses operate under the evil Pythagorean theorem. A is a distance from a center to a vertex. B is a distance from a center to a covertex. C is the distance from a center to a focus. A, B, and C stand for distances. Please think of them that way. The center is the point HK. We're done here.